Hello everyone. So this is the part 2 of our problem solving series about vector calculus. Last time we discussed how to prove that the gradient of phi, given that phi equals 1 over the magnitude of the position vector, is equal to negative r times r to the negative 3 or negative r over r cubed. So today the problem that we're going to answer is this one. Find a unit vector normal to the surface given by xy squared plus xz equals 1 at the point negative 1, 1, 1. Okay, so we have to consider first that the gradient, or we have to get the gradient del of the surface where the gradient operator equals, what is this? This is partial with respect to x, I hat, plus partial with respect to yj hat, plus partial with respect to z k hat. And then we operate this one to our equation for the surface. Okay, so we have operating this gradient operator to xy squared plus xz squared, xz. Okay, so we have partial with respect to xi hat. This is for the gradient operator, plus partial with respect to yj hat, plus partial with respect to z k hat, times this one. This is the equation of the surface. We have xy squared plus xz. And then just like last time in our part 1, we have to really distribute this one. Okay, so we have to distribute these things. So you have partial with respect to x, partial with respect to x of xy squared plus xz I hat. This is for the first term. And then we move to the partial with respect to y of xy squared plus xz j hat. And then for the last term, okay, we have partial with respect to z k hat, okay, of xz or xy squared plus xz. So we just have to actually perform this operation. No? So we have partial with respect to x of this first term. Obviously, we have y squared plus z. So we have this one, I hat. And then with respect to y for the second term, so we have 2xy, because we have to take 2 down. We have 2xy. Okay, and this will be constant. So this is 0. So we have 2xy j hat. And then plus, for the third term, we have to get the partial with respect to z. So we have only x k hat. Now at negative 1, 1, 1, so we actually just have to substitute these values to x, y, and z. So we have, for the first term, we have y squared plus z. So we have 1 squared plus 1. So that is obviously 2 I hat. We have 2 times negative 1, which is x. No? This is x, this is y, and this is z. Okay, so we have negative 2j hat, and then we have x is negative 1. Okay, we have negative 1, so we have 2i hat minus 2j hat minus k hat. Now, a unit vector normal to the surface is obtained by dividing the above vector, which is this one, by its magnitude. Hence, the unit vector is, okay, this is the calculated vector, this one, the one that we have just calculated. And this is the magnitude. Now we have divide by the magnitude. So this is 2 squared plus negative 2 squared. So obviously this is 4, this is 4, and we have negative 1 squared, this is 1. So we have 4 plus 1, that is 9. And we get the square root of 9, that is 3. So obviously we divide 3 from all of this terms. So we have 2/3 I hat minus 2/3 j hat minus 1/3 k hat. Okay, so I guess that's all. If you have some questions or clarifications regarding this topic or problem solving, you may send them via email, or you may just comment your suggestions or questions in the comment section. Thank you.